Okay, this is exercise 11.4, question 14 in similarity proofs. In the diagram shown, we are told that AB equals AC, and we are also told that E is the midpoint of FD. Now, this E is the midpoint of FD is actually not written in the textbook, but it is meant to be there. So just make sure you write that down in the question. We have to therefore show that EH is equal to EC. Firstly, I'm going to put the markings in because E is the midpoint of FD. Now, once again, we're told that AB is equal to AC. Hence, ABC is an isosceles triangle, and we can say that therefore that angle ABC is equal to angle ACB because they are base angles of an isosceles triangle. And of course, we must state that AB equals AC. So I'll just put those little angles in there to show that they are equal. Okay. We also know that AB is parallel to EH. So therefore, this angle ABC will be equal to angle EHC because they are corresponding angles on parallel lines. So we can put that in as well. And we can write that in our proof. So we've got angle EHC is equal to angle ABC because they are corresponding angles, reason being that they're equal because AB is parallel to EH. Remembering that whenever you quote corresponding alternate or co-interior angles, the corresponding and the alternate are only equal if you have parallel lines, and co-interior only add up to 180 if you have parallel lines. So it's very important to put that AB is parallel to EH. So here we can see that this angle EHC equals angle ECB because they're both equal to what angle ABC is equal to. Because if we look up here, we've got angle ACB equals angle ABC. But we've also got that angle EHC equals angle ABC. Therefore, angle ACB must equal angle EHC because they're both equal to angle ABC. Hence, we have an isosceles triangle here. So we, therefore, EH equals EC because they are sides opposite equal angles in that triangle. So we can say equal sides lie opposite equal angles. That's the first part of the question done, part A. Next, we have to prove that triangle BFD is similar to triangle HED. Now, we can see that D is a common vertex in both those triangles. And we can also see that angle FBD is equal to angle EHD with these little dots there. So we can start with that first. So angle FBD is equal to angle EHD because they are corresponding angles, because we know that AB is parallel to EH. We also know that angle D here is a common angle, and I've just marked in angle D there, and we'll just write that in our proof. So angle D is a common angle. We can actually write that out in a little bit more detail. We can say that angle FDB is equal to angle EDH, reason that angle D is common. And therefore we do have enough there to prove that these two triangles are similar. So we've got that the angle, those little dot angles there are equal, and we've got the common angle at D being equal, and therefore we can say that triangle BFD is similar to triangle HED because they are, the reason being that they are equiangular. Now that we need to do some ratios, we're going to draw the two triangles separately, indicating all the corresponding angles. So I've just got these two triangles drawn separately. And we can see triangle FBD here with the dot there at B and the angle there at D, and triangle EFD with the dot there at H and the same angle there at D. Now this makes if we do this, it makes the next part of the question a lot easier. So we have to find the ratio of FB to EC. Now we can see in these diagrams we actually have FB, but we don't have EC. But we do have, we know that EC equals EH. So what we can actually do is do the ratio of FB to EH. And that will be the same as doing the ratio of FB to EC. So to be able to do this, we need to compare FB to EH with some other side lengths in the triangles that we know. Now in the question, we were told that E is the midpoint of FD, so therefore we know that FD is double the length of, say, ED. So we can start writing up our ratio. So we can say FB over EH, now we know that FB is in the bigger triangle, is equal to FD over ED. Now, because, and that ratio is equal to 2 over 1, because we know the ratio of FD over ED is 2 over 1, because FD is double the length of ED. And the reason we can write that is that E is the midpoint of FD. Then we can say, we can look at the question, what we're trying to do. We're really trying to find the ratio of FB to EC, but we can say, but we know that EH is equal to EC, which was proven in part A above. Therefore, we can rewrite the ratio and say, well, therefore FB over EH is really equal to FB over EC, which is equal to 2 to 1. And now, remember, ratios can be written as fractions, or they can be written as ratios side by side. So writing FB over EC equals 2 over 1 is the same as saying FB, the ratio of FB to EC is equal to 2 is to 1. And that's the end of that question.